All right, everybody, let me try this in a way that I hope is not too confusing for everybody. Let me just in general say that this is the general equation, right, of a quadratic equation where we've got ax squared plus bx plus c equals 0. This is a quadratic equation, right? And if we solve this, I'm using a capital ABC on purpose. So I want you to keep this straight in your head, okay? If I were to solve this, I would say x is going to equal the opposite of b plus or minus radical, right? B squared minus 4ac over 2a. That's how I would solve this equation. All right, now here, keep in mind, I want to find the inverse formula for this quadratic. So first thing I'm going to do is recognize that this right here, f of x, I always plot on the y-axis. So we'll call that y, right? Now remember also, when I find the inverse function, I switch around the x's and y's. So I'm going to make this x equals a y squared plus by plus c. All right? Now I'm going to solve this equation right here. I want to solve this for y. If I could solve this for y, then that will be the inverse function. All right, so let's try it and see what happens. We're going to get 0 equals ay squared plus by plus c minus x. Now looking at our general form up here, looking up over here, look, a is the coefficient of the quadratic term, so capital A is little a here. It's hard because everything's a variable, right? We don't have any numbers. All right. Capital B is little b, but what's interesting about this, and this is probably the big O moment, that the capital C is the little c minus x. That's my constant term here. You know, x isn't what I'm solving for, so x is considered a constant in this equation. It's y that I'm solving for. It's y that I need to know the answer for. So when I solve this, I can do this. All right, so now this means that, therefore, y is going to equal the opposite of b plus or minus radical, okay, b squared minus 4a, and now again, because capital A is little a, capital B is little b, that's fine, but capital C up here, this c right there, is c minus x, okay, over 2a, and there it is. Now that's really my solution. Let me erase this, because now let's look at what the two different equations would be that define the inverse functions. There's actually two of them, right? So keep that in mind now. So the inverse function, one of the inverse functions, will be this right over here. It'll be the opposite of b plus radical b squared minus 4a c minus x over 2a, and the other one will be the inverse function of x. You know, inverse function 1 of x, maybe we could call that inverse function sub 2 of x. It's going to be the opposite of b minus radical b squared minus 4a c minus x over 2a. All right, remember A, B, C are you're going to know what A, B, and C are. And so once you know what A, B, and C are, it's easy to find what the inverse function would be. You replace the A, B, and C with whatever the coefficient of the quadratic term is, B, the coefficient of the linear, C will be your constant up over here, and then that x will be your only variable at that point, once you know what A, B, and C are. This is just the generic general form. So this is the solution. Hope this makes sense. Okay. Save as. Section. it's not working. Come on. Hmm.